Let's continue from yesterday, please. Before we solve any practical problem, I still have to continue from yesterday.
So you got, yeah.
Now, let's talk about the exact gradient. When you've got exact gradient, which means you can have your answer in pi. You do not actually have to simplify it. Alright? Have your answer in pi when you've got exact equation. So that will be a very typical calculator free question. So what you need to do is first find the gradient.
Yep.
The gradient, to find the gradient you need to find dy dx, correct? Yeah? So to find dy dx, you must differentiate 2x sine x and x squared cos x. So what happened is, this one, you've got a product rule with this one and product rule with that one. So differentiate 2x, which is 2, multiplied by sine x, plus differentiate sine x, which is cos x, times 2x. So that's how you do the first one. Second one, you differentiate your 2x, which means your x squared, which means you have 2x cos x, and then you differentiate your cos x, which is sine x times x squared. So from there, you need to substitute your x equals to pi. dy dx when x equals to pi. Or you can simplify it or collect like terms first. It's up to you. Sometimes I like to do that. Sometimes probably not. In this situation, I think could be slightly easier when you collect like terms. So substituting x equals to pi, so you can work out that the exact gradient is minus 4 pi. That's it. And if you're asked to interpret minus 4 pi, it's negative slope. This would potentially be a test question. This sort of thing. It's the more complicated bit is actually doing the dy dx. But once you've done that, you should be able to substitute pi in. You should know your unit circle. All right. Now, example 9. You need to determine the equation of the line perpendicular to the tangent to y equals 10x over x at the point pi 0. Now, note that this is called normal, you should know, alright? So, in this case, you must remember gradient of the tangent, let's say n1, and times perpendicular to it, n2 has to be minus 1. Alright, so therefore, you need to find dy dx of y equals to 10x over x. This time, you use your quotient rule, correct? Using your quotient rule, you know that the denominator is x squared. Alright, then we differentiate 10x. Now, for me, in this sort of situation, I would actually not use the quotient rule. I would use y equals to 10x multiplied by x to the power of minus 1. So I avoid using the quotient x squared because you know that 10x is 1 over cos squared. Avoid the confusion.
Did you find the coordinates?
So I ended up, I think, I did not. I wrote that this way. But sometimes, to avoid the confusion, do this. Alright? I don't even know how I solved it. Can't remember. So I actually did it that way. It really doesn't matter. So to avoid confusion, sometimes you use that y equals to 10x because then you really avoid that sort of issue.
Mistake.
Alright? I wrote it out the long way, but in this case, you can avoid that sort of issue. But you should still work out x when dy dx, when x equals pi is 1 over pi. If you do it that way, so that is dy dx
Pi is just 0.
will then be equals to 1 over cos square x times x to the power of minus 1 plus minus 1 x to the power of minus 2 and 10x. All right. Still the same. It depends on what you want to do.
Thanks.
Yep.
Just check that.
Yeah, sure. All right. So from there,
You went to school.
you know that n1 times m2 is minus 1.
There you go.
So therefore m2 is minus pi. You know your x coordinate and y coordinate. So therefore y minus 0 equals minus pi times x minus pi.
Oh, it's
So that's all.
perpendicular. We're actually doing
Perpendicular. Perpendicular is m1 times m2 is minus pi, minus 1, alright?
Didn't read the question.
Again, this could be a potential test question.
Yes.
In the upcoming test?
No, I don't know. You cannot ask me a question like this.
Why not?
I actually can't remember what I wrote.
That is a fun. That was a fun question.
Yeah,
How many marks would that be?
that would be possibly 2, 3, no, hang on. 2 for the first column, 2 for the second column, 4.
4 marks.
4 marks.
Out of like.
Yeah, out 4 marks. So that would be dy dx. That's 1 mark. That's 1 mark.
Rework on the second one.
That's recognizing that that's 1 mark.
You're in
and
your head, bro.
Exactly, that's 1 mark.
No, I'm not.
It depends who is the writer. Some teacher might say that this is a 3 mark question, 3 to 4.
Oh, we need class pad.
Okay, this one
Okay,
you
class
need to
pad.
show that it has 3 stationary points. What happens during stationary point?
So boring.
Stationary point means dy dx equals to 0, correct?
Yes.
Thank you. So you need to differentiate e to the power of cos 2x.
Yes.
Differentiating that, you need to differentiate cos 2x as well. Alright? And then e cos 2x. So use your chain rule, differentiate that, and differentiate e cos 2x. Which means you've got minus 2 sine 2x e to the power of cos 2x. Alright, substituting substituting dy dx equals to 0 in. You know that e to the power of cos 2x can never be 0, correct? Yeah? So you know that this bit, e to the power of 2x, this can never be 0. So therefore, minus sine 2x equals to 0. Again, you got to think about the domain. Because the question gives you the domain of x. This is sine 2x, solving sine 2x, you must think about the domain.
Double the domain.
Yes, double the domain because of 2x.
Which one do you put in brackets?
Alright,
What brackets?
so therefore you should be able to solve for x. I'm going to give you a couple of minutes to do that.
Sir, can I go to the bathroom?
Yeah.
really quick?
So tan x is one function, x is the other function.
So you can see that when you do the differentiation, you always look at the big thing and then look at the individual components. Alright, so the whole thing is this e equals to cos 2x, then the individual component is that. Alright? Yeah? So, see, I draw my, I increase the domain, and then I change the domain, and I draw my unit circle. So I know that is 0 at those points, and you could work out 2x is minus pi, 0 and pi. So therefore x equals minus pi over 2, 0 and pi over 2. Now, you got to be really careful. Sometimes the questions are really tricky. Sometimes the question will give you less without the equal. Alright? Or sometimes it just give you this or that. Alright? So therefore you're going to make sure that you know which one to include. Be really careful in the exam. I've been caught up in that sort of question before. So therefore you can substitute and you can work out the coordinate, exact coordinate. 3 of them. And again, this would be just about right for the exam type of question.
These numbers.
When you need to determine the coordinate.
Isn't cos 0 1? So it's just number E.
Yeah, it's just E.
It's
so.
just E, so it's not 1.
Sorry?
Because E cos to the
0
0 is
is
E
1.
to the 1.
E cos.
So it's just E.
Oh, yeah, E cos 0. Sorry. It's not 0. I was looking at the 0. Alright, my fault. I'll change that. E cos 0 is E, obviously. Oh, gosh. I was looking at a 0, for sure.
I actually had a good lesson.
I wasn't looking at a cos 0. Alright, my fault. I will change that. So, the next one, 4 examples only. The last example is the hardest.
No
Alright, I
way.
will go through the last example with you very carefully.
That's easy.
So this time you need to model the context involve periodic phenomena. Let's have a look at example 1 first. Alright? What I've done here is I've factorized the tan sine pi over 2t minus 3 out. Looking at the transformation.
Is this calc free, sir?
I can't remember.
No.
No, it's not. It's not calc-free.
Okay.
Not calc-free. Not calc-free.
So it's calcium.
It's not calc-free, I don't think. So if you look at a question like this, if you're asked to sketch, what I do is, the way I do it, if you want to use a calculator, you can use your calculator to sketch it. But if you don't have a calculator, I look at what the equilibrium is. The equilibrium is 25, correct? So, and the starting point is 25 as well. Because it could be 0. Is there 0? It's at the equilibrium. Right? So when it's 0, it's at the equilibrium, and that's all the starting point. Got it? So, and here,
For the grade,
the maximum,
yes, but then you would
this
find
will
the
be 1.
perpendicular line to that.
Correct? And the minimum is minus 1. Correct? Minimum for this, if you look at that, sine maximum is 1, minimum is minus 1. Right? So if you don't have a calculator, if you don't have this bit, if you need to determine that, you have to work it out this way. Work out what sine pi over 12t minus 3 equals to 1. Work out what t is. So I can work out what t, and then I work out when it is minus 1. Work out what t is. So I know the 3 points. I know the starting point, the maximum, and the minimum. If you use your class bag, you can get these 3 points quite easily. And you need to be able to sketch it, the shape. And stop at 24. Alright? I mean, I don't know what this point is if I'm sketching. I know these are the maximum, minimum, and that's the starting point, that's the equilibrium. So I know it doesn't go all the way up, and I start at 24. That's all. You've got 24. This is the shape of the graph. It's sketching. And then you need to determine the rate of temperature increase at noon, which is, therefore you find dy dt, d capital T over dt. And of course, you don't have to worry about the 25. You just have to differentiate that. I'll let you do that.
Noon is
12 o'clock.
sorry, t equals 6, my brother.
Yeah.
Equation.
All right. So differentiate this.
I didn't
Differentiate sine
fully do it because I
pi,
didn't realise
which is
the,
cos that,
problem
and
did work.
differentiate
So
that,
I did, like,
which is only
is this one?
pi over 12. So this is how I work that out.
So would you want decimal points?
Sorry?
Would you want decimal points or like
normal pi?
If it is
Oh,
calculator,
never mind.
assume you with 2 decimal places.
2 decimal
Generally, generally 2 decimal places,
That looks right,
unless
yeah.
the question asks.
Fine.
There'll be question which may ask you for 3 or 4 decimal places. All right,
So-
but if not, assume that it's 2. Yep.
For that question, right, would you have to write out the derivative, or can you just go straight to the like?
If it is
derivative?
calculator section, you don't have to write out the derivative. You can just go straight.
Okay.
So,
All right.
So,
Yep.
does it start at 25 because you have a phase change of negative?
Okay. So if this is 0,
How's it
what happens?
negative?
There's an equilibrium. And when t is 0, that is
Was yours negative?
0.
No, just
Yeah,
So it's
but
25.
if there's a phase
So
change.
how did you get negative 1.85?
That substitute that in. That's my calculator. That gave me negative 1.85. So at
Oh,
the
it's
No,
because
you
you
did
subbed in the
12.
wrong number, sir. You have to
It's
because
from
it starts at
6 a.m. Yeah.
Starts
So-
at 6 a.m. So it's only 6 hours.
oh yeah, okay. That got me. Okay, I didn't read the 6 a.m. Sorry, it's my fault. Yeah, it is 6. Yep, I was fix that up. It is 6. My fault. Please. Okay, that's 6.
That's disappointing.
So 6, you can see that it's increasing. It's not decreasing. I was looking at 12. Yeah, I thought that was right. Yep. Okay, somewhere there. It's actually 6. 1, 2, 4, 6. That bit. It is positive. I was looking at 12, which is negative there. All right, it is positive. So my fault. All right, I will change that before I upload it. My fault. All right. So again, I think I would have interpreted that. Okay. Now, when you answer a question like this, you work out the number. The best way to answer it is like, if I work it out to be negative, I would say the temperature is decreasing. That is how you interpret. Alright? So you don't give a negative number,
'Cause I
you say
set it
that it's
down, so-
decreasing or increasing. Remember that.
How do you do that?
So, yep.
So I just like shift this.
I don't think
Okay,
it
so like
stops. I think the line
shift
is
this and it
25.
does that and it changes 24.
Sorry?
If you sub in
So
0,
at the end of the solve, you just
you
chuck
still have
it
the
out.
-5 before,
What,
so you still get a sign value.
that?
Isn't
Sign.
You know what shift
still
keys
get
are,
a
right?
non-zero
Yeah, yeah, I
start
have
value
shift
for the
solve.
sign.
But
Yeah.
that's when this is 0. Oh, minus sine t pi over 4.
Yeah.
That is true. That's true. That's true. It's my fault. I didn't. Yep, that's true. That's true. So I should have used a calculator to do it. Yeah, it's my fault. So I forgot the minus pi t over 4. I just look at the t. That's all. When I look at t equals to 0. So it is 10 times minus sine. Yeah, my fault. So that I will have to update the PowerPoint. So there's something wrong with this point here. This is correct, but that's incorrect. Alright? It's my fault.
So,
Yep.
oh, actually, never mind.
I know that 25 is a what, but the starting point is incorrect.
Oh,
Starting
yeah,
point is
true.
incorrect. I will sort it out. Starting point is incorrect. So this is generally how you do it. You can solve that, and you know that t equals 7 or 33. And of course, I
Yeah, you
state
got that
it's
right as
yeah,
well.
7. Yeah, it's not 7 a.m. and 11 p.m. I got to think about.
So that means 23 doesn't count, right?
Yeah.
Because that'll be past 24 hours.
For the first 24 hours.
Yes.
Yes.
So it'd be past 24 hours. So
Yeah.
23 would be
Yeah.
the thing.
I made a lot of mistakes in this one. So I should have started 0, something else. Yeah, my mistake. Yep. T equals 0 is at 6 a.m. My fault.
Yep.
You know
It's,
how it be.
Jules, you still have to think about, because it asks you to plot for the 24 hours. So 0 here is 6.
Yeah,
6
yeah.
hours.
Yeah.
6 a.m. So you got to go to 6 a.m. the next day. Alright,
Yeah,
my
yeah.
fault.
Oh, so you have to. Oh,
Yeah, you actually have to go to 6 a.m. the next day.
oh okay.
Yeah, you do.
For the first. Oh, yeah, because it doesn't ask you for one
Yep.
day. It asks you for.
Alright, next one. Example 2. The depth of water d meters in the mouth of tidal river 3 minutes after high tide can be modeled by this. So determine the average rate of change. Now average rate of change is just the slope, right? So you need to find y when t equals to 3 pi over 4 and y when t equals to 3 pi over 2. Alright? So you are looking at the average. It's not the instantaneous. Average is the slope. From point 1 to point 2, the slope. Average is the slope from point 1 to point 2. So you need to think about y when t equals to 3 pi over 4 and y equals to when y equals y when t equals to 3 pi over 2. So you need to work out your y. So therefore you can work out your average rate of change or the gradient. Then you need to be able to determine the expression for the rate of change of depth. The expression for the rate of change of depth is just dy dx. So you must think about how you could differentiate this term. You must think about how you could differentiate this term.
Can't you just
Alright.
use your calculator?
You can use a calculator if this is calc free. Yeah, I think this is calc assumed.
Yeah.
So here it's just 2 cos t over 6. Alright? Take the whole thing first as cos t over 6 all squared.
Yeah.
Alright? So therefore you do that first and then you do your cos t over 6, which is minus sine t over 6 and then 1 over 6 because of the this gradient.
That's
That t over 6. Yep.
they have to. Isn't it 2 times 2, so it's 4 at the front?
2?
Because there's already a 2 already there.
Yeah, it is.
So
No,
it's
I'm
4.
just looking at that first. I'm just looking at this.
Oh, okay.
I haven't multiplied the 2 here.
So it's times 2, yeah.
Out there. For sure. So I'm working out to be 2 over 3, not 3 over 2. 4 over 6 is 2 over 3. That's 2 over 3. Alright? So I'm sure that I would have done an error in the next one. It's 2 over 3, not 3 over 2. That's 2 over 3. Alright? And then you will be able therefore to determine that. Substitute t equals to 3 pi over 2 in. These are all calculator assumed. Use your calculator. B, you can determine the expression using your calculator. That's all. And make sure that it is not in decimal, it's in standard. Alright? So if you use your calculator, now let's go to, let me write it down.
How's the 2 with
2 cos squared t over 6. Alright? Let's use your calculator. Have you got a calculator?
One over 6.
If not, come and
Yeah,
grab one,
because the
please.
4. You have the 4. It's
Alright,
2
if you
times
use
2.
a calculator,
4. Then you substitute the 1 over 6 in, so it's 4 on 6, which is 2 on 3. And then negative sign makes it negative.
so
Negative
under main,
So
make sure that you clear all variable if you do your dy dx. So to keyboard, if you're not sure, go to keyboard, d dx.
negative 1 on 3.
That will be 2 times. Now make sure that you, when you do something like this, put in a fraction, which is x over 6. Alright? Make sure that you square the whole thing. you need to put appropriate bracket in. So this one, x over 6 belongs to the cos, that bracket belongs to the square. And then, see, when you do differentiation, never put decimal. Always go to standard. Then you've got your answer. Alright? It's different from what I've done, but this is still correct. Alright? So the calculator will give you a slightly different. It will just combine everything and simplify everything. Whereas I don't really simplify it. Right? So now, example 3. Example 3, I am going to go through very carefully, and I'm not going to go through step by step. 3 and 4, pretty difficult. Now, example 3, I am combining a trigonometric function with a displacement. Now, if you're talking about displacement, here, I have not defined whether it's positive or negative. Alright? So some question will say that positive is to the right, or up, or wherever. Alright? Or forward or backwards. Alright? Some question will do that. Some question will not. So in this case, you just have to say that it's positive direction or negative direction. Now, when you are asked to determine the initial location, velocity, and acceleration, you must work out the first and second derivative. Alright? Here, at this point, it will ask, sometimes it may ask you to describe the motion. What would the motion be at t equals to 0? What would the motion be?
1.
Read carefully again. So the location is 1 meter from, positive 1 meter from the origin. Alright? Not talking about location, I'm talking about motion. The motion is that it is traveling at a constant speed of 1 meters per second because there's no acceleration, correct? Acceleration is 0. So if you're asked to describe the motion, you should always describe it as whether it's constant velocity or it's a velocity at something and it's speeding out or slowing down. Yep.
Isn't negative cos 0 negative 1?
Yeah, it is. It is negative cos 0 is negative 1. So my fault, negative cos 0 is negative 1. So it's therefore negative 1. So it is slowing down. Alright? That should be negative 1 and therefore it should be slowing down.
For 3.
Thank you.
B.
So there's negative 1. If you're asked, it's slowing down.
Did it ever go
Now,
stationary?
when you look at a question like this,
So,
P is stationary when xt equals to 0.
Why are you using 20?
You can either
Isn't it
use your
like
class back to plot
2
it
pi
out.
on 20?
Alright? Plot it out, or this is a difficult one. This is a really difficult one because the graph looks really interesting. I will plot it out using my software.
Okay. I think it's...
So I'm going to show you this one and the next one in a few minutes.
oh wait, I did it wrong. Do it with yours, I did it.
Did you?
Yeah.
I didn't get 13 pi on 2, so...
I got it. You got pound 2, 5 pound 2.
Yeah, I didn't get the last one.
Yeah.
Sir, are you sure 13 pi on 2 is within
I'm not
20
sure.
seconds? Because I don't... It doesn't... When you do it on your calculator, it doesn't say it's within 20 seconds.
No, I'm not sure. I might be wrong. I might be wrong. So,
How did you find the maximum? Did you sub it in?
Yeah, just use the F max function. 7 pi on 2 and then 11 pi on 2, yeah. So,
Determine the rate at which. So you find the maximum point.
or legit use f max function. Like,
So you just find the maximum point
yeah. Across the domain, yeah.
across the domain.
So for the last question, can you use? I mean, for part C, can you use f max?
Sorry?
For part C, can you use f max in a calculator?
Which one?
F max, the function.
Not sure. That one I'm not sure.
But would you get marked down if you used it?
Sorry?
Would you get marked down if you used it? Because it's not using calculus. Yeah. Okay.
Don't think so. Alright, now, this graph looks something like this. This is the graph, for example, the second last example, example 3 today. You can see that if you plot the graph,
This.
there's a stationary point here, stationary point here, stationary point here, stationary point here. Alright? And you can also see that maximum speed or maximum velocity will occur here. And it's sort of a repeat. Correct? So you can see that at this point, all this point, is actually when dy dx equals to 0. And then at this point here, the oblique point of inflection is where the maximum velocity will occur, or maximum speed. And it should always be the same. Yeah? So it's once you find one, you know
Max speed.
the maximum speed.
Is when x is at 26.
No, I got 3 pi on 2,
Alright.
7 pi on 2.
Do you all see that? You can see here, this point, this point, this point, and this point. It's horizontal.
Because
That
this is
is
velocity, right?
velocity is 0.
F maximum velocity. Right?
Now, if I plot on the graph, this is that function. This is the function y plus x cos x. So what if I plot on the graph
So I can't be bothered. Can you
the
just
first
tell me what-
derivative? See, this is the first derivative. You can see that all this,
Yeah. It's 3 pi on 2, 7
This
pi on
is
2,
where-
9 pi on 2.
3 pi on 2.
when it is 0,
7 pi on
is
2.
where
And
11
this-
pi on 2.
there's a stationary point. Alright? And this is where there's a maximum velocity. I mean, I'm lucky I have this that I could plot the first derivative, but I don't think your classmate could do that. So I could observe where the stationary points are.
So is number 4 calc free? Well,
None of them. I don't think that all these questions will be calc free.
but last question you can definitely do calc free.
You can if you want to. If you want to ask question, but I don't think so. Alright. So the last question, if you look at the last question, let me save this one.
I'm gonna do it calc free. Cool like that.
Yeah, calc free is not that bad anyway.
Oh, nice. Okay. So the next one.
So what were the second differential?
Sorry.
What were the second derivative on that one look like?
If you want to look at the second derivative, hold on. The second derivative will look like.
How do you solve it for 0 though?
Spec, mate. Remember spec?
Oh, bish off, mate.
Something like this will go all the way up and down, up and down.
Do you
but I
expand
haven't plotted
sine to
whatever
it?
yet. Alright?
Yep.
Now, last
Really
question.
not that deep.
I'm just gonna use
Don't
solve
deep
function
it.
A.
Don't deep it, bro. It's not even that deep. Expand it. Factorize out 2 cos x.
Alright, let's have a
It's
look
easy.
at the last question.
I'll just factor.
The last question again involved what you learned last year. You go. The last question involved what you learned last year, because when you find the first derivative, you have 2 sine 2x. You need it to be 0. How do I actually work that out, sine 2x and cos x? So therefore, you really need your knowledge from last year, which is your angle sum. Sine 2x is sine x plus sine x. So therefore, is sine x cos x plus cos x sine x, which means you got 2 sine x cos x. Alright, that is important. You need to recognize that. Alright, if you don't recognize that, it's pretty hard for you to solve when x equals to 0. If you don't have calculator. If you've got a calculator, you can solve it. But without a calculator, I got x equals to 3 pi over 2 and x equals to 5 pi over 4. Because sine cos x equals to 0, sine x equals to half. Now, recognizing that this sign here, x is greater than pi over 2 and x is less than 2 pi. Alright? Remember that. If not, you will have got other solution. You must not have that. Read the question carefully. So see what you need to learn, what you need to remember. This bit, sine 2x, is sine x plus x, which is 2 sine x cos x. If you remember your formula from last year, your angle sum.
Isn't it if
don't
the
know whether it's
derivative,
in,
if the double derivative is a positive, then it's a minimum,
Yep.
is it not?
So you got the derivative wrong.
You don't have the angle sum from,
So you got the double derivative wrong.
have I?
It's concave up.
Yeah, it's supposed to be
Because when it's positive, it's
Plus-
a minimum. Isn't it?
no, it's supposed to be plus 2 cos 2x instead. Because you use
That
product
is-
rule, right? No, I'm talking about the actual.
That's mean, that is
Math.
No, I'm talking about the
max.
actual.
So, okay, alright.
Mixed.
Second
So
derivative.
second derivative is minus 2 sine x, and then, oh, I'm just looking at this one. Alright, so that is 4 is,
To find out if it's a
Minus-
max or a mean, brother.
it is minus 4 cos 2x. 2 sine 2x
It's
is cos
negative
2x.
2
4.
sine x.
Yeah.
Take 4. Yeah,
It's
it
4
is,
cos
yeah,
x.
right.
It's 4 cos 2x.
Okay.
That's right. So I got these two inverted. That's mean and max. Alright. Now I can plot this for you as well. I'll show that. I'll show this. Y equals to 2 sine x plus
So, did you?
2x. Yeah.
Oh, you can't really check for. So, cause the greater than and
Yeah.
signs are only like it's not equal to, then you
Yeah, it's
don't,
not
you don't
equal
check
to.
them. You don't check pi on 2.
Sorry.
Do you not check pi on 2 then?
You do have to check pi on 2 as well, because it's just under that. Always check pi on 2.
But it shouldn't. It's not included though.
Yeah, it doesn't matter. I'll show you the equation. I'll show you the graph.
It's not in the domain.
Yeah, but it's going to approach that, right? Like go
You
very
have to
close.
think about that.
Did you? He didn't even check it
He
though.
said max for the 2. How is that possible?
No, it's mid. He said it was. What'd you say? Oh yeah. Dan got pissed.
Alright. The graph should look something like this.
What was Dan mad about?
I invited Bradley to the office because he was really.
The graph should look something like this.
Yes.
So I was like,
Although it doesn't include those 2 points, you really need to check the extreme.
hollow dot.
Alright? You really need to check these 2 points that even just under there is not higher than that.
Afterwards and then
Alright?
bad and
It's
spec.
not lower than that.
Higher rank.
So make sure that you check the 2 point as well, although they are not included in there. Alright? You can see that this is the maximum, this is the minimum. If you use your class back, you really need to make sure that you are within your pi over 2 and 2 pi. Alright, like I said, I've got the advantage of using the fx graph. That I can see exactly what it is. I know this is the maximum, this is the maximum, this is the minimum.
Could we graph it and then?
You could graph it, let's
and then,
try
and
it
then
on
we
the
write
class
like,
back.
and then if we write like
Using CAS.
inspection. Of
No,
graph.
you could use your, let's graph it with your class back and try it.
Inspection of graph means
Oh, you can't.
global
not-
as well. No.
There's one. Yeah, it's a one mark question. So if you use a graph.
Alright, let's use your class back. Play around with the class back.
You can literally just chuck in F max within the domain.
Yeah, you can
can.
type in fmax, but I haven't really used that function before, so I
True.
Yeah.
Alright,
So it's a
let's
2 mark
go
question.
to,
It's a 1 mark
F max
question.
and F min.
No, it's legit a 1 mark question.
No, because you have to do
Oh, min
max
as well.
and min.
Oh,
So
yeah.
2 mark.
Yeah, yeah.
Surely you
make sure
can't
that
just
you
do
clear
that.
everything.
I mean,
That's just cheating.
you would say like using calculus techniques though.
Probably. Not necessarily, but if it doesn't.
No, it doesn't, you can do it,
down.
yeah.
Can you go back to page 4?
Unless it says like explain.
So question 4. Nah, don't worry about it. It's wrong. Well, it's not wrong, but I just messed up on the diffing because I did cut free.
You could, I think.
Just face ID.
Yeah.
That's sick.
I mean, it is right. Be fuck finishing it.
Yeah, do you want the answer?
Yeah, it's 3 and 2, right?
I just copied it.
Yeah, it's like
I didn't feel like it.
5.6 and 3.
Go back to question 4.
I know. Alright, now if you use your class back, this is what it looks like. This is what it looks like if you use your class back. So it's different from what I did. What you need to do is be
Set the
able
domain.
to
You have to change the domain.
change it.
Yeah, I know how to do that. You know how to do
Alright?
it?
Make sure that x min is
Do you know how to do it?
Yeah.
uh,
Are you sure?
I'm pretty sure, bro.
Pretty
X
underground,
is-
bro. No one people
Nah,
know
yeah,
how to
no
do
one's
it.
pretty.
Alright?
Gatekeeping
Restrict the scale.
I gatekeep that.
I'd gatekeep it.
So if you restrict the scale
It's
from
so easy.
pi,
Because everyone, when
you
they go
know
for
that you can see this point and
when they
that
go for the
point.
salt.
You miss how Fonzie told the whole class about it.
Hey, listen. You can use your class back. Analysis, you can go to analysis, go to GSolve.
Sine.
Yes.
Yeah, you can use fmax.
Do you have?
That will give you where the maximum point
I don't have
is.
a set up.
Alright.
Come on.
Because this is my sister's. I
So
did
does
change
F
only.
max
I only
mean like
changed
global maximum?
Yeah, I think so.
You got
How do I
diff as
get
well?
local?
Local, you just have to look for max and mean.
But I'm
Oh,
just
come
like,
on, mate. Come on.
That's,
Max and
it's
mean.
not hard to search
Alright.
for the diff.
Come on.
Max
come
and
on.
mean. That's all you can do. Max and mean. Fmax is the global maximum or the global minimum. You can see that the global minimum is the same as local minimum. So you could use your class pad if you want to, but you must restrict it to the domain.
What do you
You
have
must
in
learn how to
domain?
restrict it to the domain. You can try it again if you want to do that. X min is pi over 2.
No, yeah, but like, what?
Oh, that button.
Yeah, okay.
And then X max
That
is 2
button,
pi.
bro.
Alright? A little bit better. If you restrict the domain, you can straight away find out the X max, F min. So analysis, go to GSolve, X max, that's the maximum. Analysis, go to GSolve, F min, that's a global.
Right, do you have to start
And
with
then
zero?
GSolve, maximum,
2 pi.
Yeah.
GSolve, minimum. Alright? Now, the last question, it's
Good, mate.
this question here,
Poppy.
you could use ClassPad. I went through step by step. Hey, I went through step by step and show us.
Better have the energy, bro.
Yeah, it's not going to be a calculator assumes question. It's going to be really long to solve it in a calculator free section. So it will have to be a calculator assumed. You can if you want to. So you can see that I went through and worked out the local mean, local max, and then work out the global mean and global max. So if you use your calculator, it will save you a lot of time. Wrong one. If you use your calculator, it will save you a lot of time.
There we go. I got it.
So can you go back to the first question?
Now, make sure that you know how to use your calculator in during exam, because there will be question in the count assume section that you can use your calculator and work it out straight away.
Yeah, but I don't think it's.
All right. Now I'm going to stop.